linear motion products, electromechanical actuators are used in a lot of different applications. Are there maybe particular industrial automation applications where they are best suited, or you're seeing them being used more frequently at the moment, or is it just pretty widespread?
It's pretty wide, and we have there's obviously a big macro trend with more automation happening in a huge range of industries. We see it in construction equipment, we see it in agriculture equipment, we see it in factory environments. Of course, this is the obvious one, but also in food industries and so on. So it is linked to labor shortages and cost reductions and so on. But there's really, this is a big macro trend that is going to continue. So from that point of view, there is really there's a big need to automate certain functions and automate certain applications. And sometimes it is a partial application that is automated, and in some cases it is completely automated. The more automation happens, the more also precise control is needed. And usually with electromechanical actuators, you can position them very well. Comparing them, for example, to fluid power, the controllability and the positioning performance is a lot better. And from that perspective, we see really that these are the key requirements that are driving continued use of electromechanical actuators.
Mm-hmm.
And it's really, yeah, I mean, people talk about AI and robotics. AI is everywhere. Everybody talks about AI. No one really knows what it does, except to create maybe cute, cat pictures. But
Yeah.
AI is really, it is the brains behind implementing a lot of artificial intelligence in different systems. But if you think about what actually does the motion in the background, so something's got to move, and in robotics, something's got to move. So the components that are actually moving the systems that are being controlled by AI, those are the kinds of systems, the applications where the linear motion components and systems are installed. So it's really, AI is driving automation, but the motion has to happen somehow, and that motion is coming from these linear systems.
Mm-hmm. Mm-hmm. And so are you seeing, since you kind of touched on, their use instead of fluid power technologies, are you seeing electromechanical actuators or other linear motion products being used in place of hydraulics and or pneumatics more frequently now in industrial automation applications? Or do you see that continuing to grow? Or I guess just kind of, since we have a lot of fluid power people in our audience, they're curious to know, how is that trending, and where do you sort of see that going?
Yeah, definitely we see that, but it depends again on the application and the need. We have often, if there's a system or a machine or a factory environment that has a lot of pneumatic lines and a certain additional access is required, it's obviously easier and simpler to just install an additional cylinder. The cost is lower in the control system. Everything is already there. The benefits of electromechanics are usually, again, the precision and the controllability. The other aspect is also that a lot of these electromechanical actuators are basically virtually maintenance free over the lifetime. So there could be benefits in terms of total cost of ownership, looking at the life cycle of the machine. And there could be benefits in terms of positioning to improve the performance and the output of the machine. Those are benefits that are, sometimes they're obvious and there's a clear value proposition, to install that. And sometimes there's a need to continue with what is there. What we do see is that the efficiency of electromechanical actuators are higher. So with efficiency being higher, there's a lot of drive by companies or customers trying to reduce carbon emissions, trying to reduce energy usage and save cost that way, to basically invest in that technology and to improve overall efficiency and reduce energy consumption. What we see often is certain applications that require maybe one or two functions that are far away from an existing pneumatic power line or an existing hydraulic line. installing all these extra lines is a huge cost factor. So in that case, it becomes a lot easier to just put in a power line for an actuator and run that additional access with an electromechanical actuator. So it really depends on where it's being used.
Mhm.
What we see though is that with a lot of new designs, if someone is basically developing a new machine or a new setup or a new uh, feature from scratch, that electromechanical actuation is really usually the choice because of benefits in, as I said, controllability, energy efficiency, maintenance, TCO, and often in certain industries, let's just take medical application, food application, it's the risk of contamination if you have oil, for example. So having kind of a clean room environment with actuators is easier to achieve.
Do you ever see potential opportunities to kind of pair or utilize in tandem the electromechanical and fluid power technologies, because kind of hybrid systems at all, or do you kind of feel like it's maybe a one or the other situation?
No, I think it's possible. I think it depends on the complexity of the system and how the system is designed, especially the control system, how they work together. That's something every engineer needs to consider. It is possible. It doesn't mean that it's one or the other. And often, some of the larger pneumatic integrated companies, they offer both. They have electromechanical and pneumatics, and depending on the application, it's this or that. So
Well, I think just to kind of wrap up our conversation, how do you see linear motion and electromechanical actuator technologies kind of continuing to evolve in the coming years? Or what further features or capabilities will customers be looking for, or companies like Schaeffler need or want to offer customers?
yeah, we need to stay on our toes. We need to be pivot left and right and make sure that we adapt to the big macro trends that are happening. I mean, what we see, what is happening is really, first of all, as I said, we need to be able to provide solutions that meet the customer needs. So just providing a standard off-the-shelf product is not going to do it. We need to be able to adapt the products. But the key trends that we see is there is definitely a trend to improve or increase the power density of actuators. So really, in the same footprint, the same size of a cylinder of an actuator, provide more output, more lifetime, more performance, more accuracy. So more for less. At the same time, we see also that in certain applications, also the cost is coming down with more usage of electromechanical actuators, getting more into this hydraulic space. We see the cost of actuators and actuator designs is also partially coming down. The cost of motors is coming down. So in the long term, we believe that with the volume adoption of this technology, we will see more and more actuators being used instead of hydraulics. Maybe one interesting one is also we've all heard about or seen some of these humanoid robots out there. The humanoid robots are the future in some form or another. We will see them around in the future. And if you think about those robots, they have a lot of actuators built in. They could be rotary, could be linear. There's a bunch of different technologies, but this is where really having a more compact actuator with more power density and higher efficiency. Higher efficiency is also a key trend, will be essential because these are mobile vehicles. These are mobile robots walking around on a battery. So the battery power is limited, and they will have to provide more power for a longer period of time. So really efficiency, power density, and the size and the footprint, I think, of these actuators are going to be important. And yeah, so I think that's a key trend that I see in the future.